Water is the most significant cause of damage to the roadway pavement and its underlying support section. Properly constructed road surfaces are relatively impervious. The hard surface protects the base support material from water and prevents surface softening and erosion. A properly constructed surface has a crown with transverse slopes on each side to drain water to the edge of the pavement and the shoulder. Side ditches collect the runoff and convey it to a discharge point, such as a convenient cross drain or an adjacent stream bed. In urban areas, water is contained by curbs and gutters at the road edges to convey the discharge to a drop inlet or a catch basin. If these basic drainage features are not provided, the result can be pavement breakup, potholes, cracking, shoulder disintegration, base saturation, and eventually total pavement failure. For these reasons, the quality of your maintenance and rehabilitation program is key in helping to keep water away from your roads. This film will discuss drainage considerations including surface and subsurface drainage, drainage systems, and inspection of these systems. Pavement deterioration that starts with poor drainage cannot be effectively corrected by either construction techniques or maintenance procedures. The drainage problem must be solved first. Maintenance of road surfaces to keep moisture from entering the base through cracks in the pavement is vitally important to the stability of the roadbed. Surface maintenance can be divided into two broad categories. Routine repairs, such as pothole patching, crack and joint sealing, and leveling, and preventive maintenance, such as surface treatment or seal coating. The timing of both types of maintenance is extremely important to extending pavement life. There's truth to the saying, if you don't know what caused the pothole you fixed today, you will fix it again tomorrow. Routine repairs, such as full or partial depth patching, skin patching, crack sealing, and leveling, must be made promptly to reduce the need for more extensive repairs later. In addition to performing maintenance at the right time, the proper type of maintenance must also be performed. Most seals add little, if any, structural strength to the pavement. As the name implies, sealing pavement seals the surface to protect the pavement from deterioration and penetration of water. Thus, seals must be applied before the pavement loses its structural strength. Seals are designed to provide one or more of the following benefits: to seal the pavement, preventing the intrusion of air and moisture, to fill small cracks and voids, to rejuvenate an oxidized binder, and to provide a new wearing surface. Preventive maintenance also includes maintaining the cross slope. Aggregate surfaced roads are graded higher in the middle than at the sides to form a crown that lets water flow into the ditch. Good drainage requires a crown of 4 to 6% measured from the center of the roadway to the outside edge. Roads with poor crowns trap water, causing the crust to become saturated and break up, eventually producing potholes, washboards, and a poor riding surface. A groove at the outer edge of the road surface should be avoided, or a secondary ditch will be formed, preventing proper drainage. Full-width grading should be done instead. Money spent on the maintenance of drainage systems directly affects the long-term cost of all roadway maintenance by slowing deterioration and reducing the scope of future repairs. Water, if not removed quickly, will either lower the supporting ability of the subgrade material that supports the pavement or will simply wash it away. When water is prevented from saturating the subgrade either through correction by underdrains or prevention by a properly functioning drainage system, the investment made in the street is protected against premature loss. Drainage inspections should be made quarterly and during and after each major storm to evaluate the need for cleanup and repair. The best time to look at drainage facilities is during a storm. The inspector should be alerted to any pavement cracks or settlements that appear after a severe storm, even if these defects are small, as they may be evidence of a larger problem. Ditches must be kept free of silt, debris, or any other material that restricts the flow of water. The flow lines of unlined roadside ditches are maintained by motorized equipment supplemented with handwork. Large roadside ditches are sometimes located at an elevation well below the roadway and are not accessible to a motor grader. These may be reached with a truck-mounted hydraulic excavator operated from the shoulder. Outlet ditches from culverts and interceptor ditches on slopes and along excavation or embankment benches may require hand cleaning by using shovels and wheelbarrows. Ditch erosion is controlled by paving the ditch with a bituminous asphalt aggregate mix, placement of masonry, grouting rock, or by constructing wash checks. Since erosion is one of the major problems with ditches, the growth of vegetation is encouraged. The vegetation may be maintained by adjoining property owners, but more often must be maintained by the Public Works Agency. One of the major problems when vegetation is used to control erosion in ditches is the control of weeds. Weeds become a major problem in turf when grass loses its vigor and density and cannot compete with them. Weed encroachment is often the result and not the primary cause of poor turf. Weed eradication often will not result in permanent improvement unless conditions that weaken the turf are corrected. Culverts must be kept free of obstructions. Sand or sediment deposits should be removed as soon as possible. During storms, critical areas should be patrolled and inlets kept free of debris. Inlet and outlet channels should be kept in alignment, and vegetation should be controlled to prevent significant restriction of flow. Scour around footings, cut-off walls, and head walls is repaired by replacing the eroded material in kind or by filling the void with riprap or sacked concrete. In an emergency, a bituminous mix may be used. Culverts may become clogged if the flow line grade prevents self-cleaning. A permanent correction is to relay the pipe on a steeper grade, but this is not always possible. The alternative is to clean the pipe frequently. If the invert of a metal or concrete culvert becomes worn or eroded, it can be repaired by relining with concrete grout, gunite, or asphalt cement. If the hydraulic capacity of the culvert is not critical, a smaller pipe can be placed inside and the space between the pipes can be filled with pressure pump Portland cement grout or gunite. High velocity flows containing large quantities of stone and rock scour the culvert bottom. Scour may be reduced by securing steel plates longitudinally along the bottom. To prevent erosion, energy dissipators are sometimes placed at outlets of culverts and sewers. It is important that these be inspected periodically, particularly after major behind the backslope can supplement the system. Vegetation or erosion-resistant material should be used on side slopes. Bank protection is required when stream flow or wave action endangers highway embankments or structures. Erosion may be controlled by rock slope protection, grouted riprap, or other materials available locally. Velocity of flow and direction of currents are critical factors in selecting materials. With any bank protection, take care to prevent the protection from being undercut by erosion. The leading edge of the protection should also be shielded from erosion. Other drainage appurtenances that need to be inspected and maintained include wash checks, energy dissipators, head walls and slope drains. As with all structures, inspection should be directed at critical areas that could fail. Slope rounding can easily be introduced in normal slope dressing maintenance activities. Not only will erosion rutting be reduced by this operation, but also the safety aspects of the hinge point will be improved. Sodding or seeding and mulching will help reduce erosion. Erosion ruts on the front slope are particularly undesirable because vehicle wheels can be trapped in them, thus steering recovery back towards the travel lane is impaired. Ditch cross-sectional modifications can often be combined with debris removal operations or slope dressing operations. A safer cross-section can often be obtained by converting V-ditches to flat-bottom ditches and using the extra material removed to better blend drainage inlets to existing terrain. In some cases, ditch relocation can represent the safest improvement. Slope flattening can push the ditch further away from the roadway, both of which produce a safer roadside. Ditches near crossroads or driveways can be relocated to remove the pocket that results when ditch culverts are used. Many factors that adversely affect the performance of inlets and culverts can also be identified during routine maintenance operations. Some can be corrected easily with maintenance equipment and forces. Those that would require design changes or substantial reconstruction can be identified and programmed for future safety improvement projects. There are factors that can be identified and corrected during maintenance activities. Is debris accumulation impeding water flow substantially? Does the particular drainage structure require excessive debris maintenance? Is there evidence of substantial soil erosion around the opening? If there is, would the installation of a concrete apron, riprap, or relocation or reorientation of the opening correct the problem? Is the opening flush with the surrounding terrain features, or does it constitute a pocket that could trap a vehicle? If the opening is inclined, could it cause vehicle ramping? In the performance of some of these routine maintenance activities, several environmental issues arise, including pollution and permitting. Several types of pollution can occur in adjoining waterways, including sedimentation, turbidity, and toxicity. Maintenance activities that cause sedimentation and turbidity include repairing slopes, cleaning ditches and channels, repairing drainage structures, and other repairs performed on the right-of-way that produce loose materials that can be washed into the waterways. Vegetation control is the primary maintenance activity that can introduce toxic materials into adjoining waterways. Whenever an existing channel is being modified, it may be necessary to obtain a permit before the work can begin. Permits may be required by both federal and state agencies. The federal agency permits are generally required whenever a navigable waterway is affected. States may require permits for other waterways as well. Liability for accidents caused by elements of design and maintenance are also an area of concern for public agencies. Most liability claims stem from maintenance deficiencies. The lack of timely maintenance or repair work to correct known problems can increase the possibility of legal action, particularly if the public is injured or land or buildings or crops are damaged through the negligence by the highway agency. Several legal precepts exist that are important to any maintenance program. The duty to correct a dangerous situation or take appropriate action arises when notice is received of a problem. Under the concept of constructive notice, the duty to act may arise when the agency should have known of the existing situation. Let's review what we have talked about in this film. Since water is the most significant cause of damage to the pavement structure, proper water drainage is important in maximizing the life of the roadway. Roadway design has been developed to keep water away from the pavement structure. This is usually done by providing a watertight surface, slopes to channel the water away from the pavement structure, ditches to collect the water, channels to carry the water from the ditches to a point of discharge, and underdrains to keep subsurface water from infiltrating into the pavement structure. To keep the design functioning, perform both routine and preventive maintenance on the pavement surface and its drainage system, ditches and channels, drainage structures and slopes. Any work that is performed must be done in accordance with established procedures to reduce the effect such work may have on the environment in terms of sedimentation, turbidity, and toxicity. Some types of maintenance work can require personnel certified in correct procedures. Although the preservation of the road is the primary reason for performing maintenance, consider the potential for legal problems that could result from lack of maintenance of facilities or improper installation or design. It is often maintenance personnel who are the first to spot inadequate design. The importance of proper drainage and competent maintenance can mean better roadways, keeping within maintenance budgets, and can save lives of those who travel over the roadways. Make it a top priority in your area.